What's up, guys? Today I'm going to be taking a group of STL files given to me by a client. She purchased a prefab armature that she wants 3D printed, but we need them to fit her body and the proportions that she has. She sent me a list of measurements. It's going to be armature for her arm. So I'm going to take those measurements, I'm going to put them in to Blender, and I'm going to scale her STL files to fit her specifically. So let's just get into it. Starting off, I'm going to take a base model for a human. I think this is a male, but this is just sort of a simple reference, so I can make sure proportionally we're right. Next thing I want to do is drop in all of the STL files and start getting them fitted. Here I actually got lucky. All of the STL files were kind of already in an arm shape. They came in very nicely. I was able to put them up against the model that I have here and was able to just get everything into a nice starting spot. All right, so the first step of the process, I mean, besides importing stuff and getting a reference arm, is I'm going to be making the basic shapes that will represent the sizes and dimensions that were given to me by the client. So here I'm going to start off with a cylinder to represent the bicep. I was giving a circumference of her bicep. Using simple geometry, I was able to turn the circumference into a radius, put it into Blender, size the cylinder appropriately, and just give it a simple depth. I just kind of picked arm length. I don't know. This was a guess. This is not important. As you can see, that cuff that's going to go around the bicep only goes halfway up. So the depth size or length was far less important. A super important factor in this is meters in Blender equal millimeters in an STL file. So when you take this and you import it into your 3D printer slicer, by default though, in Blender, meters translate to millimeters in a real life scale. I've never bothered to change it because I know that to be true and it hasn't let me down yet. It makes sizing things for real life models so much easier if we can wrap our head around that. So we have a bicep shape here. I'm gonna sort of just get it all fitted to that shape. Next we have the forearm. Same thing with the circumference to radius of the forearm. But here we do have a length to work with. The length of the elbow to the wrist, I'm going to take and I'm going to put in as the depth of the cylinder. So that depth is now the length of our forearm example. Obviously forearms kind of taper as they come down. So we could mess with it and we could size it, but I don't have a partial distanced circumference to work with. So I'm just going to accept that the front of the forearm cuff will clip into our reference. The biggest thing is just making sure the back of it is sized for the circumference that we were given. Okay, so here you might notice that there are some extra pieces that I've added just for a length example. The measurement was from the outside of the elbow to the wrist, so the inside of the elbow naturally will clip into the bicep shape. So I added a length just so that way I could see what's happening there. I'm going to follow it up with the wrist circumference and then a basic cube shape for the hand width. That's really the only measurement I was given was the hand width. So I'm going to try to keep everything scaled proportionally, and then I'm going to put it back over that arm model that I had to work with to begin with, just to make sure proportionally things are making sense. As long as nothing too crazy happens, it should fit. Next thing you want to do is save all of your pieces as individual STLs, so they go into the printer exactly how you'd want. Right here, I didn't want to save each piece of the hand individually, so it's important to get them rotated and spaced in Blender like you want them to print in the slicer. Here I've got everything rotated so they print upwards. If you do 3D printing, you know how hard it is to print certain things at the wrong angle. Next, I'm gonna bring everything right down to 0 on our Blender floor. So that way everything has a nice starting spot in the 3D printer. Everything here is gonna have supports and stuff like that, so it's not crucial that it has a flat base. And then, yeah, you're good to bring in your STL files. And as long as every measurement that you were given is accounted for and put in, well then, you know, we should be good. As most projects go, you get a curveball here and there. For me on this project, the length of the forearm was wrong, so the hand got spaced sort of goofy. And I ended up going back in and redoing that part. But, you know, you got to work with the information that you have and do the best you can. Yeah, no. All right, well, and now everything is good to go off to the printer. So that's the end. That's it. That was a speed run on how to size things in Blender for your 3D printed STL files. All right, guys, that wraps up the tutorial for today. Hopefully we learned something. If we get 3D prints right on the first try, it's gonna save us all a bunch of time and money. And yeah, if there's anything else I can cover for you, please comment it below. If you want to support the channel, please like and subscribe. If you want to support Brain Butter as a whole, I do a bunch of other things, VR chat worlds, music visualizers, 3D printing. I'm going to post my Patreon down in the description. Anyway, that's it for now. I'll catch you guys in the next video.